Welcome to Leetcode's Blind Curated 75, where I'll be solving the top 75 Leetcode questions. This question is called Decode Ways. It's a pretty classic problem. And here's the question. Decode Ways. A message containing letters from A to Z can be encoded into numbers using the following mapping. A equals 1, B equals 2, so on and so forth, all the way to Z equals 26. Now, to decode an encoded message, all the digits must be grouped, then mapped back into letters using the reverse of the mapping above. For example, 11106 can be mapped into AAJF with a grouping of 11106 or KJF with a grouping of 11106. Now, note that the grouping of 11106 is invalid because 06 has a leading 0, can't be mapped to F. Even though we can convert that to an integer 6, it has to map to the exact string here. Okay, so one of the things we should kind of keep note is having zeros is going to change our logic a little bit. So let's first begin by trying to build some intuition here. Let's just begin with like two character strings. Like what sort of intuition can we build from looking at some of these examples? Well, the first thing we can see is that if the very first number is a 0, this should be return 0 immediately because there's no way to decode this. Like, it doesn't matter what comes after. If it just starts with a 0, there's no way to decode that, so just return a 0. It's almost like an error. Now, if the number is valid, so if it's 2 digits and it's between 10 and 26 inclusive, that actually means there's two ways to decode it, right? Because we know every single digit, as long as it's not a 0, we can always decode that to one way. But if there is a way to group it together, we have at least two ways there. But if the number is out of bounds, if it's not between 10 and 26, that means there's only one way. So that's one thing to note. But if it's a 0, things become a little bit different. If it's a 0 here, there's only at most one way to decode this, right? We have to make sure that the previous number before is basically a 1 or a 2. Like, it has to be between 10 and 26. Here it's going to be a 1, but if it was like greater than this, 90, this actually is kind of like a return 0 immediately as well because there's no way to decode this. It doesn't matter what numbers come after this. At this point, we can't decode it, so that's kind of like a dead path. It's over. Okay, so that's one thing to note. So what we're going to do is take care of some edge cases, and we're going to do a DP solution. We're going to keep track of the number of ways we can decode this at each position. Like here, we can see this would be like just both 1 and 1. There's only one way. Here, this would be code it one way, and we code it this way. And depending on what comes after, say that this is like, I don't know, like a 3. If it was a 3, 23 is valid, right? So that means that we could decode this by either adding this just by 1, so add that to here, so it'd be 2, or take whatever comes before here and add this, so that would be just adding these together, so that would be a 3. But if this was like this, then we can see that this isn't valid, so at most we can just take whatever comes before here, and that would be 1. So this would still only be one way to decode this at this point. Okay, so hopefully that kind of makes sense. Let's begin taking care of some edge cases. We'll first say if not S, if it's an empty string, or the very first character is equal to a 0, just immediately return 0, because this is like an error, can't decode it any further. One other thing, if the length of this string isn't 1, if length of S equals 1, that means there's only one way to decode it at this point, so we'll just return 1. Okay, so let's begin by first initializing our n, the length of S, and we're going to create a DP array. This would just equal to first all zeros times n. So let's first set our base cases. dp0 is equal to 1, right? Because we know it's not a 0, so we know there's only one way to decode it. That's going to be 1. But what about the second character here? Well, it depends on whether this is a 0 or not. It kind of changes our logic. So if, let's see, if s of 1 is equal to 0, what do we want to do? Actually, I'm going to do the opposite way. If it's not equal to 0, well then let's first see if we can decode it or not. So to do that, what I'm going to do is just say if s of 0 to 2, if we convert this into an integer, is it in bounds of 10 to 26? And if it is, then dp of 1 is going to be equal to 2. Otherwise, if it's not, then we know that there's only one way to decode this, so that's a 1. Now, if it's a 0, though, we have to make sure that it's in bounds. Like, it still needs to be in bounds here. But at most, it's going to be equal to 1, right? Otherwise, if we're not able to put this in between 10 to 26, there's no way to decode it. It's like this example here. So this has to be return 0 immediately as well. So, okay, so now we can just follow this logic, building upon the previous 2 elements from our DP array. So for I in range of 2 to n, what are we going to do? Well, we're going to be following the same logic here, but instead of s of 1, it's going to be s of I. If it's not equal to 0, then we're going to go from I minus 1 to I plus 1. Now, if this number is between 10 and 26, then dp of I is actually equal to the 2 paths that we can calculate so far, right? So it's just dpi minus 1 plus dpi minus 2. Otherwise, dp of I, it's not equal to 0, but we know we can decode it, right? We can make it, it's going to be between 1 and 9. So it's just going to be whatever we've calculated so far right before. So that would just be dp of I minus 1. Now, if it's equal to 0, though, things change a little bit. If it's valid, then it's going to be dp of I minus 1. But if it's not, then we return a 0 immediately. It's kind of like the same thing here. Return our, at the very end, we just return the very last character in our very last number in our DP array. And that should be it. So let's make sure this works. Okay, it looks like it's working. And I messed up something here. Let's see, dp of I. Oh, I think this might be actually a 2 here. Let's see if that works. That's the problem with copy pasting sometimes. There we go. Okay, so basically I just made a typo there. But basically, when it says 0, right, as long as it's in bounds, we kind of can already tell, like, for example, if we had 10, 0 like this, and now we're checking, I don't know, like at this point, we're looking at the 0. Whatever we've been able to calculate at this point is what we want to look at, not here, because this 0 here that we're adding on is just kind of concatenating. So we're not like building upon that. We got to get whatever we calculated at 2 positions before. And that's going to be, there's only one way to decode this. So that's just going to add whatever ways we had decoded so far to here. So hopefully that makes sense. I mean, this definitely is not the most clean solution. It's pretty fast. It's still O of n. We do use O of n space because of our DP array. We can avoid that by making these just variables, but it just kind of got messy and I just started to lose track of it, so I avoided that. You can also probably clean up the code a little bit by adding an extra space in our DP array. But you know, like sometimes I came up with the solution by just trying different things, probably the worst approach possible, just like trying different things and eventually getting to a place that I was able to get to work. Now, I don't recommend that, but sometimes, man, you just gotta mess around and see if something sticks. And in this case, this is what I came up with, so I'm just gonna stick with it. All right, thanks for watching my channel. Remember, do not trust me, I know nothing.